Hello. Today I will discuss on propellants used in aerosol formulations. Objective questions come in GPAT, which is very important. More importantly, numbering of propellants or name to number or number to name. Reverse way it is important, and it is very important component of aerosol formulations. So, what are different propellants used in aerosol formulations? The basic propellants used are hydrocarbons (HC), fluorinated hydrocarbons (CHF), and compressed gases. So, all have their importance. These fluorinated hydrocarbons are important, but they have the limitation of their environmental pollution, which has the limitation of causing environmental hazards. So that is the limitation. And compressed gas as nitrogen N2, carbon dioxide and nitrous oxide. These are the compressed gases used as propellant in aerosol formulations. And hydrocarbons, propane, butane, isobutane, these are the hydrocarbons used as a propellant. And everybody, as a basic of chemistry or physical chemistry, Raoult's law, that is relative lowering vapor pressure by addition of a solute is important, and Dalton's law of partial pressure, which is also that the total pressure exerted is the summation of the pressure exerted by all the gases present. So those are also basic things. And coming to this nomenclature of propellants, which is important. Nomenclature. This nomenclature is given by refrigeration industry, which is a numerical designation. And I will give you this, make you to understand with the giving example. And the very common thing to remember is just to make it remember. So you can simply remember as the CHF, CHF. So finally I can tell you in pharmacology, cardiovascular system, CHF is congestive heart failure. So CHF. So here for a numbering of propellants, C is for number of carbon atoms, H is for hydrogen, and F is fluorine atoms. And the number is given as, suppose for example, I will tell you 011. So the first digit is for carbon, the second digit for hydrogen, and third digit is for fluorine. And the number of carbon atom is given after making -1. So as the number is given by making -1, and hydrogen number is given by making +1, and this number of fluorine is as it is mentioned. So actual will be, we have to, for carbon we have to make it +1, for hydrogen we have to make it -1, and fluorine atom, as I told, as it is. This is the way. And for example, suppose 011, as I am discussing. So as it is 0 given after making -1, so actual number of carbon atom is 0 plus 1, so 1, so it is C. And hydrogen, it is given, it is +1. Actual will be, we have to make it -1, so the 1 minus 1, it is 0, so there is no hydrogen atom. And the third digit is the number of fluorine atoms, so it is 1, so number of fluorine atoms is 1. As we all know, carbon is tetravalent, and the valency of carbon will be satisfied by adding number of chlorine atoms. So this valency we can add with the chlorine. So this is 3 chlorine atoms is to be added. So for its nomenclature, it is as C comes first, F second. So trichloro, monofluoro, one carbon atom is methane. This is a number to name. The same thing, suppose the name is given, we want to convert into number. So it is a trichloro, 3 chlorine atoms will be there. Monofluoro, so 1 fluorine atom is there. So it is one fluorine atom and it is 1 carbon atom methane. So for C, H, F, so this, if we want to make it number, as there is methane, 1 carbon atom, so number of carbon atom is to be assigned by making -1. So as actually it is 1, we have to give the number as by making -1. So it will be 0. And the hydrogen atom, here there is no hydrogen atom, and hydrogen atom should be assigned by making +1. So we have to 0 plus 1, so it is 1. And fluorine atom, it is monofluoro, so there is 1 fluorine atom, so 0, 1, 1. Similarly, we can name 0, 1, 2 also, for example. So 0 means, so this is C, this is H, F. So by making -1, it is written 0, so actual will be 1, so 1 carbon atom. So by making +1, the hydrogen is noted with 1, so actual will be 1 minus 1, it is 0, so there is no hydrogen atom. And 2 fluorine atoms, so this is F, F. And the rest valence will be satisfied with adding chlorine. So dichloro, methane with the nomenclature. So this is one. And reverse also, from name we can go for numbering. So this is very simple thing. And coming to this property of these propellants, so usually when there is only number, that indicates it is a symmetrical propellant, and if the number of isomers increases, so and there is asymmetry, we can denote with small a or b or c. And A is more asymmetric than B, B is more asymmetric than C. So this is understanding. And if this ABC stands for asymmetry. So this is one. Asymmetry. And for cyclic compound, we can write with capital C. So this capital C indicates it is a cyclic compound. So we can take one example of a cyclic substance. So the cyclic compound we can take C318. So this is so if it is C318, this C stands for it denotes it is cyclic. 3, this is carbon, this is hydrogen, and this is fluorine. So carbon, after making -1, it is given 3, so actual will be 4. So there are 4 carbon atoms and it is a cyclic compound, and there are hydrogen, by making +1 it is 1, so actual will be 0, no hydrogen, and there are 8 fluorine atoms. So we can write fluorine to satisfy the valency of carbon. So it is octafluorobutane and cyclic structure. So this is what. And basing on the flammability of the propellant, it may be nomenclature with A, A1, A2 or A2L and A3. So this A1 is non-flammable, and this is flammable, and this is highly flammable, or this is explosive. Similarly, basing on the toxicity of the propellant, then numbered with B1, B2, B3. So B1 is non-toxic, B2 is medium, and B3 is highly toxic. So this is about the propellants used, and it is the propellants that act as a vehicle in the aerosol formulations. In the container, it behaves as half of the propellant under pressure, the gas converts to liquid and half remains as a gas. The portion which is converted to liquid that act as a solvent or vehicle for the solute, which remains as dispersed or soluble or suspended, and half which remains as gas that helps in giving the pressure for the component to be expelled out when pressure is exerted on the actuator. So this is of the propellants. And one more thing also, we should PS, which is IA, which is one short form used, that is a pound per square inch of solute. PSIA, this notation is also used. So this much is basic, that is numbering, which is very important for GPAD. This is the discussion. Thank you.